Hello guys, this is Rupesh and I'm watching CPP Nuts video series on data structure, and this topic is circular linked list. So it's been a nightmare for a long time, right? So let's understand this now. So circular linked list is not a very big thing. It is just a modified version of a single linked list. You know single linked list, right? This is how it looks like. You have nodes here, you have this null here, this is pointing this one, this is pointing this one, and this is your head. Maybe this is 100, 200 and 300. These are the addresses, 100, 200, 300. And we have this data like 1, 2 and 3. And this is how it is. And you have this 100 stored at your head or something. This is what traditional single linked lists look like. I have a diagram for you. Don't just worry about it. So this is your diagram. Okay. And this is a linked list. We know that. And the last one store null or 0. But if you see a circular linked list, in circular linked list, last node point to the first one. This is the only difference between single linked list and double linked list. Circular linked list. So instead of this null, what you will do, you will actually point to 100, which is nothing but again this guy. So can you see this? Now you are a circular linked list. And to maintain our program, we will call this as the last node. And we will always maintain this because the benefit of having your last node, you know what is the last node in your linked list? And next to last node is your first. So if you want to have first that is always with you and last is always with you. So maintaining only one pointer gives you the benefit of last one and the first one, because obviously the next of last is the first one. So let's make this the first. So this is how a circular linked list will look like. We'll go through the program and all that. We will see all those implementation. So let's complete the theory part first. So insertion can be done at these places, like insertion at empty list, because initially you won't have anything, right? So you will insert at the first time. So this is what it is. Second is insert at the beginning of the list. We will not see this portion here. You can write your program for that, and that would be a homework for you. So we are not implementing this one. Just put this dot here, and insertion at the end of the list. Yeah, we are actually implementing this because this makes a good sense to me. And next is insertion in between the nodes. This is very good, but we are not implementing this because unnecessarily it will increase the code, and you can do this by yourself by just putting little bit amount of thoughts. So these are the insertion. Deletion can be anything. I mean, it depends on you. You can delete from the beginning, you can delete from the end, you can delete from any node, I mean in between, right? Cool. So let's look at the advantage. Shall we go with the advantage first, or we should go for the code first? I'll go with the advantage first. So what is the advantage, or what is the usage of this circular linked list, what we are learning here? So the first and most important is CPU scheduling. This requires little bit of OS knowledge, but don't worry, I'll help you. So if you have this CPU sitting here, and we have processes P0, P1, P2 and P3. So let's assume there are only 4 processes currently, and as I said, this CPU scheduling uses circular linked list. So make this as circular. And you know what? Even OS have to maintain your process. So maintaining means what? It is running your process. So it has to store those processes in some data structure, right? So that's what I'm saying. It stores your processes, or at least the head of your processes, in circular linked list. So this is CPU, and you all know that CPU scheduling is a mechanism where sometimes this CPU will execute instructions of P0, and then it has to execute some instruction of P1, P2 and P3. So there can be n number of processes. It has to execute each and every processes little bit of instructions in sequence, or one by one, not in sequence, one by one. So for now, let's suppose CPU is running P0's instructions, and maybe as it is round robin, we can assume that it is taking maybe some amount of time for this guy, and then similar amount of time for this guy, and similar amount of time for this guy and this guy, and that time is very short that you don't even realize that CPU is not working for you. So it is very fast, so even if it is switching between processes, you don't realize that, because you can play song and you can draw something, you can still code when you are listening songs. So actually it is switching between the processes, and you don't really know that if you are at this process. I mean, if you are writing code here, this is your editor process, and maybe this is your song process, which is playing a song for you. So it happens very fast that you feel that okay, it is working simultaneously, considering you have only one core processor. There can be multi-core processor, and it can actually do things parallelly for you, but for now you just understand that this is a single core processor. Nowadays it is very hard to get, but maybe in smaller computational units, smaller gadgets, you will still find these single processor CPUs. Okay, so you understood, right? It will use circular, like let's suppose if this is your first and this is your last and this is your first. So if let's suppose this is not circular, let's suppose this arrow is not there, it is just a single linked list. So your processor will do P0, P1, P2, P3, and then there is no way to go back to P2. So it has to reset itself and know that okay, I have hit null, and it has to check null all the time, and that is also a burden, right? And then if it hits null, it has to again have a track what was my first one, and it will go there, and then it will again start. So it is not looking good. I mean, why are you breaking it? Let it run continuously, because your applications runs continuously, right? So implementing circular linked list is the best data structure for this kind of job. Okay, and not only this, you might remember your network class. There also, let's suppose you have these systems, computer 1, and they all are maybe connected to the router or something, and there is only one cable coming in. So what happens, this router or switch, I don't know, I don't remember that, but the mechanism was it will share the token between your computers. So let's assume that there is some token T, and if this token is with this guy, only this guy can send the data, and after some time this guy have to release this token, and then that T will come here, and then now this computer can send the data, and then it has to release this token, and this guy will get the token, and this one will send the data. And now once this is done, you have to go back, right? So can you see this? This is again a circular linked list application. And you remember that collision avoidance, collision detection algorithms and stuff like that, and token sharing. I just recall my BTech and there was this circular linked list application there. I know that. It is good, right? I mean, if you're learning data structure, please keep this in your mind. I always tell to the people that no data structure is always good for something. Otherwise, there would have not been these many data structure. You should have just studied one topic of the data structure and that would fit in any damn application. But that's not true. You have array, you have linked list, you have tree, you have graph, you have stack, you have queue, and you have hell amount of advanced data structure based on tree and graph and stack and queue. And what advanced data structure means, you will tweak a little bit tree and it will become something else, and that would be needed for your typical application, and similar goes with graph and stack and queue. Even you can see the linked list portion. You have singly linked list, you have circular linked list, you have doubly linked list, and you have circular doubly linked list, which is next topic. Not next topic. This is the next topic, doubly linked list. So can you see this? Only linked list have these many variations. So think about tree and graph. They have so much. So as you can see, the circular linked list variation is very good at these kind of applications. and singly linked list is good for something else, doubly linked list is good for something else, this is good for something else. So it is highly dependent on your application and what your problem is, so you will pick a good data structure. That's why people call that, if you master data structure, then you can be a good architect, you can be a very good problem solver, and of course you can get job in multinational companies, because they focus on data structure and algorithms like anything, because they test your ability to go dig and find a good data structure for the typical application what they will ask you in the interviews, and that's what they judge. Okay, so this whole series is going to be a very good fun, I know that, and I will include each and every data structure. I'll try my best, and I'll find different applications for those data structure, and I'll include them so my viewers can enjoy this series like never before. Okay, so let's come back here. So CPU scheduling, correct, we just discussed this one, and now queue can be implemented using one pointer, just the last pointer, because next is next to last is always first. I don't know what I write sometimes, yeah, but it says that if you always have this last only one pointer, then you always have the first one, because the next of the last is the first one. So this is what it is saying. So you remember queue, I don't have the place here, I'll write here. So when we were learning queue, you might remember this is your rear. Okay, this is your rear, this is how we draw it. So this is your front and this is your rear of queue. So this is your queue. So you remember you was maintaining front and rear, and you was always popping out the data from front, and you was inserting the data into the rear pointer, and you was updating that pointer, and similar goes with this front pointer. You will take out something and make this one as your front, correct? But if you implement queue using circular linked list, so this mechanism was using a singly linked list which had null in the end. Okay, so you had to actually maintain two pointers, front and rear. But if you will use circular linked list, you just have to maintain the last one, and last will always point to the first. So that is another benefit if you consider that as a benefit. And the third one is application where you don't want to reset once you reach the last node. This is very good. I mean, instead of talking about the explicit application, you can keep this in your mind. Okay, because if you have something like, if you have some application which will always running in a circular fashion, then you need circular linked list. Now the question is, do you want to come back from here to here? Then actually you need a doubly circular linked list. So it is highly problem dependent. It is highly dependent on applications, correct? So we have covered almost all the theories I wanted to explain you guys. Let's look at the code now. So the code is very simple. It is not a very big thing. That's what I said in the beginning, that I will be having add to an empty function and add at the end function, and we will have simple traverse function, and this is going to be your main function. And I have copied this code from internet, so you can get it if you'll Google it. It's not that difficult. So initially, and as I said, I will be always maintaining the last one. So I'm creating this last node, and yeah, the node look like this. Node means our one node, correct? I was having this data portion and nodes next, which will store the pointer of node type, itself. So this is how it look like for your node. So this is your one node structure. So let's go through this main and we'll understand it better. So initially you created this pointer. Now you don't have anything in your hand right now, so you will create a list. So you said that add to an empty, and you send this last. So let's go to this one, and this is your data. So what is data coming in between? 6. So you're first entering 6 here. So last is currently null. So the assumption is when you are adding to the empty, it should be empty. If it is not null, means it has something, it will return that. It will say that, okay, dude, it is not empty list, you have something in it. So if this is empty, then only it will go forward. And this is a traditional way of creating a memory in C programming, or I should say a dynamic memory allocation. So this was the syntax. If you love C++ syntax, let me do that for you. So just remove everything and new and node. That's it. This will do the same job what this guy is doing here. It is very clean, right? But still, if you want to use this one, otherwise use the C style memory allocation. Okay, so we created a node, let's call it temp. We inserted our data in that. Now last becomes temp because we did not had anything in our list, right? So this is the first time we are doing something. So we created a temporary. We made that temporary data point to our data, which is 6, and then the temporary is assigned to last. So now our last is nothing but newly created node with 6 in it. Now this line is very important. This makes it circular. Can you see this? Last next is last. So data was 6. This is fine. We got the data. Now last next will become last. So what it means is it is actually pointing to itself. And because we have only one data in linked list, so it will point itself only. So don't worry about that. And then we will return this last. So come back to our main, and this last is holding one node with 6 in it. That would look something like this. You have 6 address, and this is what it is. So can you see this? It is pointing to itself, and this is your last. Okay. So after this, we will use add at the end, and we will pass our last pointer and the value. So let's go to this function now. This is your function. It will take the last one and the data. Now here I'm checking whether this last is null. So it is possible that you was iterating over the linked list and maybe deleting something, and you ended up deleting everything, and then you want to add. And if it is null, I mean if your list is null, then it will end up calling add to empty function, and it will just return from here. So we have already seen this function. So let's assume that we have 6 in our node, so this will not execute. Come back, we will create a temporary. You know that how to create it. So currently you have this state, okay, before this line, correct? Now what you did, you created a temp. Let's make it a temp here. And what you did, you created, assigned data into that. So data is 8. That's cool. Then what you did, you are saying that temps next is the last next. So what is last next here? It is 100. So let's make it 100. Okay, so we are done till this line. Now what we are doing, we are saying last next is temp. So last is this one, last next is temp. So let's make this as 200. This temp is 200. Now we will remove this. And now what you are saying, last next is equal to temp. So come here, this is your last and this is your next. So you will actually assign 200 here. So that's what it will point to this guy. Correct? So this is done. Now the last one, last is equal to temp. So come here. Now last will no longer be this guy. We are updating last. And can you see this? This 100 means this guy, right? So this is actually pointing to this one. So can you see this? It is a circular linked list. This one being first magically, because last next will always be the first one. So let's insert another, it will be very easy. So here it is saying that I want to insert 12 now. So let's insert 12. So as we will be sending last, so this time 12 is coming. So let's create another temp, and you have 12 here, and let's quickly do this time. And temps next becomes last next. So temps next is the last next. So last next is 100. So let's assign that. And then last next is equal to temp. So last is this guy. So this next will become this one. So let's assume this is 300. So as this is 300 now, this is not pointing to this guy. This will actually point to this guy, correct? And This is done. Now let's make last is equal to temp. So last is this guy. We will replace this as this guy. So now this will become your last. So can you see this? It is pointing to 100 and 100 is nothing but this one, this node. So still it is circular. So this is how you will actually maintain a circular insertion. Cool, right? So this was the addition part at the end. Now let's look at the traversal. Traversal is very simple. What you want to do is, if you want to traverse from first node, then what you will do, your last next is always first. You know that, right? So you will pass that, you will get that as a first here. You see that if first is not equal to null, what you will do, you will iterate over it. And I have created a temporary. So temporary data is actually the first data. You will print that, then temporary will become temporaries next, and this is how you actually go in the linked list, right? And once you will become another node, you will verify that another node is actually not the first node where you started with. So if it is, you will terminate the loop. So let's quickly run this application and verify the correctness. So G++, this is your fourth video. Compile this, compile successfully. If you'll execute it, you will see that 6, 8 and 12. So we inserted 6, 8 and 12, and now you're getting 6, 8 and 12. So this traverse is also working. So we'll stop here. Thanks for watching, guys, and don't forget to hit the like button. If you like this video, don't forget to subscribe if you're new to my channel, so that you will get the notification for upcoming videos like this. I will see you in the next videos, guys. Bye bye, take care.